Hello everyone, welcome back to the lecture of Thalassic Academy, and today we'll be talking about the Three Musketeers of Oceanography. Does anybody know who are these Three Musketeers? These Three Musketeers of Oceanography, how I used to call them, Three Musketeers of Oceanography, are our temperature, pressure and density. Okay, so everybody who is in oceanography or in any kind of environmental sciences knows how these three parameters are really important to study any type of either aquatic environment and majorly the marine environment, isn't it? So today we'll investigate how this temperature, pressure and density goes into the vertical and horizontal trends in the ocean. Okay, so our first musketeer will be temperature. Okay, we'll take temperature into the consideration. Let's start with a fresh page. So I will denote temperature as temp. Okay, so would you guys be amazed if I tell you temperature is not real? Shocked, huh? Temperature is not real. According to me, how much I know it, how much I understood it, the thing is we have something called heat. Okay, and heat is calculated in terms of energy, which is our joule. Okay, now if I tell you today is 250 joule is falling upon us, it's a bit hard to get our heads around the concept, right? So temperature is the thing which will give us the measurement of heat or cold, in the sense we can say it's a positive negative thing. Okay, so temperature, for commonly it is measured in Celsius and Fahrenheit, or for a scientist it is Kelvin. Okay, so temperature is a tool by which we can measure heat or the energy. Okay, I think that's clear. So what is the primal sources of heat on our planet? In my view, there are two primary sources. One is solar source and secondary is inner source. Now inner means the radioactive heat coming from our Earth's core. Okay, so these are two primal sources. But as we talk about the crust, we talk about the ocean, this solar part becomes more and more dominant. So in this discussion we'll ignore for some time this inner radioactive heat part. We'll concentrate more on the solar part. Okay, now let's say this is my ocean. Okay, and here will be my sun. So sun sends its radiation. Okay, so now the solar radiation came from the sun and it first enters the atmosphere. Okay, so in atmosphere different type of process happens, which is our scattering, reflection, refraction and other thing happens. Okay, then it finally enters into the ocean. Okay, now this heat trend can be seen in two ways. One is horizontal and other is the vertical. Okay, so first we'll see what happens in the horizontal trend. Okay, in horizontal trend we'll write here horizontal. let's say this is my sun and here is my earth tilted on its axis. Okay, so this will be my equator, this will be my pole. Okay, so when the solar radiation comes, don't you think the equator is closer to the sun rather than our polar part, right? We can see it easily in diagram. So our equator will be warmer. Okay, our equator will be warmer and polars will be colder, right? Because there is a tilt in the earth's axis. Now why this tilt exists, how it affects the spin and the revolution and the precession motion, we'll see in some other class. Okay, and in between there is a region called temperate region, which is good of the better of the both the worlds, which is slightly hot, slightly cold. Sometime of year it's very cold, sometime of year it's very hot, so it fluctuates. Okay, so in the horizontal trend we can see equator will be the warmest, then slightly warmer temperate zone, then polar zone will be the coldest. Okay, warmest, this will be the warmest, this will be the coldest, and this will be the moderate region. Okay, so this is the horizontal trend of temperature which occurs because of the tilt in the earth's axis. Do remember this, why the horizontal trend happens on earth, because of the tilt in earth's axis. Okay, now we'll see the vertical trend, vertical trend of temperature. Now let me make a vertical diagram of oceanic system. Okay, in detail we can cover this in the marine provinces chapter when we consider or will teach the marine provinces. We can cover this different zone and their properties. Okay, in here I will tell you the briefly what they are. So this is my ocean surface. Okay, this is my benthos. Clear? So my light is falling on the ocean surface. This is my solar light or solar radiation, you can say. Okay, so the uppermost surface of the ocean, it can penetrate very easily the radiation. This zone is known as epipelagic zone. Okay, now in between there is a mesopelagic zone. Okay, in this mesopelagic we can divide it in two parts, which is one is my dysphotic region. Now what this dysphotic region means, light will come but in small amount. Okay, it will come in small amount, and the other half of the mesopelagic zone is called aphotic zone. Okay, or aphotic zone or aphotic region, because after this region, after this line below the dysphotic region, there is absolutely no light which penetrates. Okay, no light penetrates, so there will be a pitch darkness in this region and below this region. So we can categorize this as the epipelagic zone will be my photic zone, where there is complete penetration of light. Now in mesopelagic there are two subzones. One is dysphotic zone. In this the light comes and attenuates. It goes dim and dim and dim. And after the half of mesopelagic area, it goes complete into pitch darkness, because the penetrative power of our solar light diminishes. Okay, So only the upper what we can say 2 or 3% will be penetrated by the solar radiation. Other thing will be in complete darkness. All the below 4 layers will be in complete darkness. Those 4 layers are the half of the mesopelagic, then the benthos, bathypelagic, then abyssal pelagic and hadal pelagic. All these 4 layers will be in the pitch darkness. So how temperature affects it? So only 1.5 layer is penetrated by solar radiation. That means only those layers will be getting the solar heat. To understand it, we can say the surface temperature of ocean is 35 degrees Celsius, but the bottom temperature of ocean is only 2 degrees Celsius. See how much difference is there. So where solar radiation is pakka and it is receiving very nicely, it is 35 degrees Celsius. But in the bottom of the ocean where there is pitch darkness, no solar radiation, it will be 2 degrees Celsius. Now we will talk about the pressure. Okay, the pressure variations in ocean. So in horizontal part, okay, in the horizontal trend, there is nothing much to discuss in the horizontal trend, because when it is in the horizontal spectrum, our atmospheric pressure is our surface ocean pressure. Okay, so how our atmospheric pressure is changing, that means our ocean surface pressure is changing. Okay, in a sense we can say it depends on the temporal changes. Somewhere sometime it is a low pressure, somewhere sometime it is high pressure. Okay, we cannot actually quantify how ocean pressure is actually in a horizontal trend, but we can study in a brief manner when we discuss ocean currents and cyclones and other kind of physical things. Okay, so we'll directly jump into the vertical trend. Okay, so let us make a vertical diagram of the ocean. Okay, this is my ocean. So at the atmospheric level, I am approximately having 1 atmosphere pressure. So this surface layer is also having 1 atmosphere pressure, because Earth has only 1 atmosphere. So we had made us in a standard ki okay, whatever atmospheric pressure is there, that means 1 atmosphere. Okay, ideally. Now as we go down in the ocean, okay, the pressure increases. That means let's say I am at this point. Okay, so all water above me will put pressure on me. If I am here, all water above me will put pressure on me. If I am here, all water above me puts pressure on me. Okay, so how we quantify it as every 10 meters of ocean will give me an increase of 1 atmosphere pressure. That means this layer, let's say I am saying at 10 meters. So what would be the pressure at bottom of this layer? Many people say 1 atmosphere, but no, it will be 2 atmosphere, because 1 we are having at the surface only, and 1 additional we are getting after going 10 meters deep into the ocean. Okay, now let us take one example or a problem. Let me say there is a hydrothermal vent. Hydrothermal vent operating at 5,000 meters. That means in abyssal pelagic zone. Abyssal zone. Okay. What would be the pressure at that point? Okay, we have to find. So we are seeing our 10 meters is giving rise to our 1 atmosphere. Okay, That means 5,000 meters will give rise to 500 atmosphere. But does the 500 atmosphere is the answer? No. The answer would be 501 atmosphere. Okay, I told you 1 atmosphere we are having already at the zero surface level. That's why 1 additional we have to add. So 501 atmosphere will be our answer. Now one question I want to leave for you guys here is, now why water doesn't become vapor here? Okay, when the hydrothermal vent heats from below, why doesn't it become steam at 100 degrees Celsius? You guys can comment or DM me the answer. In next class maybe we'll take this answer. My question is, in simple words, what would be the boiling temperature of water at this point? Okay, so you need to tell me, if my depth is 5,000 meters, what would be my what temperature my water will boil? Okay, if you want hint, I can tell you, you can use the Clausius-Clapeyron equation to calculate this. Okay, either you calculate this or either I will tell you in some further classes. Okay, now going on to our last musketeer, which is our density. Now density is a very decent guy. Okay, it doesn't have much of our vertical trend. It doesn't have much of our horizontal trend. Horizontal trend might come when two different type of water mixes. Okay, but it has a vertical trend. Okay, it's a very decent guy. It doesn't very much, and it doesn't bother us much. Just the thing is, as in temperature we have seen, the above water is hot water. Okay, the below water is cold water. Okay, and we all know cold water holds more gases. Okay, that's why cold water is more denser. Okay, and we can also know about it as the denser water always lies below and less dense water always be upwards above the more denser water. Okay, that's why hot water remains above. Hot water, in hot water the molecules will be very scattered as compared to colder water, which is more packed, which is less volume and more density, because the formula for density is mass by volume. If I keep my mass constant, decrease my volume, the density will eventually increase. That means the surface water will have low density, below water will have high density, and as we go deep down it increases. Okay, so these were the 3 musketeers of oceanography, and these 3 are the most prerequisite thing before you study and go into hardcore oceanography, because it doesn't matter any topic you read in oceanography, from small topic to small topic to large topic to larger topics. These 3 things will always be in the background, and we will be discovering them more, we will be studying them more in further lectures, as thermocline, pinocline, halocline, salinity will also come in. Okay, so I think for today this is enough, and I think you have understood all these 3 musketeers and their function and their trends. So we'll meet in the next class. Okay, see you, bye bye.